Okay, dear students, observe the question. If the expression x minus p by x square minus 3x plus 2 takes all the real values of x, that means for x belongs to R, x belongs to R, then find the boundaries for p. Then find the bounds for p. That means we have to identify the intervals of p. Now this is the question construction. Actually this is from quadratic equations and quadratic expression. So given quadratic expression, that is x minus p by x square minus 3x plus 2. So its domain is R given there, since it is defined on real number set. That's why its domain is R. Now we have to find the range of this expression. Within the range, we have to find the limits of p. Okay, now we are going to the process. Solution for this one. Let us take f of x is equal to x minus p by x square minus 3x plus 2. So this is the given function. This is the given function. X minus p by x square minus 3x plus 2. Its domain is R. Its domain is R for all. X belongs to R, where x is a real number. That's why its domain is R. Now we have to take range. Generally, f of x is equal to y. That means x is input. X is input. That is the domain. Now f of x is the range. That is output. F of x is output. That is the range. So let us consider this range is taken as y. This range is taken as y. That's why the expression x minus p by x square minus 3x plus 2 is equal to y. Now we have to identify the y limits. Now from this, apply cross multiplication. Then it is x minus p is equal to yx square minus 3xy plus 2y. That's all. Now, this can be right. Take that side. Here it is yx square minus of, take x is common. Then 3y plus 1 of x plus 2y plus p is equal to 0. That's all. So now we get quadratic equation in terms of x. Quadratic equation in terms of x. That's why for this quadratic equation, x is real. For this quadratic equation, x is real. X is real means what? For quadratic equation, that means the quadratic equation real values depends upon the discriminant of the quadratic equation, and nature of roots depends upon the discriminant of the quadratic equation. Now nature of roots of the quadratic equation. Suppose roots are real and equal. Roots are real and equal. Then discriminant is equal to 0. Roots are real and imaginary. Then discriminant is strictly greater than 0. Sorry, roots are real and distinct. Roots are real and distinct. Then discriminant is strictly greater than 0. Then roots are imaginary. Then roots are imaginary or complex numbers. Then discriminant less than 0. That's why if roots are real and equal, then discriminant is equal to 0. If roots are real and distinct, that means different roots, then the discriminant greater than 0. If roots are imaginary or complex numbers, then discriminant must be negative, less than 0. That's why the nature of roots of the quadratic equation depends upon the discriminant. So discriminant formula is b square minus 4ac. Since already that is already discussed concept is there, already the concept for nature of roots. From that concept, if discriminant is equal to 0, then the roots of the quadratic equation real and equal. If discriminant greater than 0, then the roots of the equation real and different or distinct. If discriminant less than 0, then the roots of the quadratic equation imaginary or complex roots. Okay. So, but from the given concept, the domain of the function x belongs to R, where x is real. X is real means what? It may be equal or different roots. That's why we have to take the discriminant greater than or equal to 0. Since x is real may be real and equal, may be real and distinct. That's why we have to take a discriminant positive greater than 0. That's why first of all, this equation will comparing with this is quadratic equation in terms of x comparing with ax square plus bx plus c is equal to 0. In place of a y, in place of b, minus of 3y plus 1, in place of c, 2y plus b. Are you clear? Since this one is quadratic equation in terms of x, we'll compare with this one. Now, for x is real, if x is real, then discriminant greater than or equal to 0. Then the discriminant greater than or equal to 0. Since x is real means it may be real and equal or it may be real and distinct. That's why if real and equal, then discriminant is equal to 0. If real and distinct or different, discriminant greater than 0. That's why x is real. There is chance for equal or different roots. That's why b is greater than or equal to 0. Now, discriminant b square, that is 3y plus 1 whole square minus 4 into ac 2y plus b greater than or equal to 0. Now we have to simplify this. Then it is 9y square plus 6y plus 1 minus 8y square minus 4py greater than or equal to 0. Are you clear? Now from this y square minus y square plus 6 minus 4p into y plus 1 greater than or equal to 0. That's it. That's why we get the expression is positive or 0. So here expression is positive, the coefficient of y square is positive. That's why they have same sign. So, if the expression is positive, definitely its discriminant is less than 0. Its discriminant less than 0. Again for this discriminant less than 0. Discriminant for this one is less than 0. Discriminant for this one is less than 0. Again this will comparing with ax square plus bx plus 6. Since this is quadratic equation in terms of y, this represents quadratic equation in terms of y, quadratic inequation represents in terms of y. That's why this will comparing with ax square plus bx plus c, where a is 1, b is 6 minus 4b, c is 1. That's why discriminant less than 0, that is b square minus 4ac less than 0. What is b square? 6 minus 4b whole square minus 4, a is 1, c is 1 less than 0. That's all. Now take common 2, then it is 4 times of 3 minus 2b whole square minus 4 less than 0. Take common 4 and gets cancelled. Then 3 minus 2p whole square minus 1 less than 0. Expand it. 9 minus 12p plus 4p square minus 1 less than 0. Now this can be right. 4p square minus 12p plus 8 less than 0. Now divided by 4, then p square minus 2p, p square minus 3p plus 2 less than 0. That's why the roots for this one, p minus 1 into p minus 2 less than 0. That's why this is in the form of x minus alpha, x minus beta less than 0. Then the value of x lies within the interval alpha and beta. That's why here 1 less than, p less than 2. So p belongs to open 1 to 2. So these are the bounds of p. Are you clear? Write it fast. That's all. Since here it is, this is the very important model. So, if the expression is positive, then the discriminant is negative. Okay, that's why this will comparing with x minus alpha and x minus beta less than 0. Then the value of x lies within the interval alpha and beta. That's why 1 less than p less than 2. So p belongs to 1 comma 2. These are the bounds. So these are the bounds of p 1 comma 2. Are you clear? That's why. Since this is depends upon the concept of intervals in an equation. Already in previous videos given the concept of intervals in equations. From that concept here it is x minus alpha, x minus beta less than 0, then the value of x lies within the interval alpha and beta. That is alpha less than x less than beta. Like this. Okay? Right.